All right, you guys, welcome back. Okay, so now here is a very typical AP test item. I based this on a previous AP test item that was given years ago. It's a very common thing. Put a star in there. This is the kind of thing that you need to be expected to do on a free response question on a test. Okay, consider the following problem. An oil tank begins with 1,000 gallons of oil, and that is called the anchor. Okay, that's called an anchor point. The initial values are very important to include. Sometimes the anchor point is not at time 0. Sometimes it'll be at a different time. But most of the time, the anchor point they give you is at time 0. So at time 0 hours, oil is pumped into the tank at a rate modeled by capital R of T gallons per hour. They very commonly use capital letters for rates of change. And R is differentiable and decreasing on 0 to 10. So right there, differentiable means it's automatically continuous. And you guys, you should get in the habit of writing that on your paper. Write down that the function is differentiable and therefore it's automatically continuous. Okay, and the reason they tell us it's decreasing on this from 0 to 10 is that they don't want to have a situation where the graph could go up and down and up and down and up and down. They're trying to avoid that situation. So when they tell us that it's decreasing, that means that as you increase this time, the numbers always get lower. They never go up, okay? They're always decreasing, declining, 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 and so on, okay? So first thing is to sketch a graph of this. And so for me to fit this on this graph paper, let's see, I have to go out from time 0 to 10. So I'll put my time axis here, and I'm going to go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in the y direction, it looks like I have to go up to 250. So 50, 100, 150, 200, 250. Okay, and this is in gallons per hour, R of T. Okay, and this is time in hours. All right, and at time 0, it is 250. Okay, the rate, so in other words, 250 gallons an hour are going into that tank. And then an hour later, it's at 240. And 4 hours later, it's dropped to 190. 6 hours from the start, we're at 150. And 10 hours in, we're at 140. Okay. And this has nothing to do with well, it kind of has something to do with calculus. The reason why this rate would be decreasing is they're filling oil into a tank. And so when the tank is empty, they only need to raise the level of the water to the very bottom of the tank. So the oil can gush in pretty quickly. But as the tank fills up, that top level of the oil, the surface of the oil goes up higher. And so the pump has to work perhaps harder to get the oil up to that, and that because that takes more work, it can take more time. The pump would perhaps slow down as it's pumping the oil to this higher point in the tank. And so that's one explanation of why this would be decreasing over time. So we don't know the exact path that this takes. Please don't connect these with a ruler, just because philosophically it wouldn't be that way. That it says it's differentiable, and so if you connect these points with a ruler, you're automatically creating a situation where you have breaks in the derivative, and therefore it wouldn't be differentiable anymore. So do your best to connect the dots, and what you're just trying to do is find a decreasing function that goes through those points. They're not going to award points for artistry. It doesn't really need to be super accurate, but just philosophically, please don't connect the dots with a ruler. I know that that's something that math students really like, good math students like to do, but when you do like this, you suddenly have a break in your derivative and it's no longer differentiable. So it has to be a smooth curve that's decreasing. Okay, then it says each square on your graph, in quotes, each square on your graph is actually a rectangle since the two scales are different. In other words, this is 1 hour here, and this is 50 gallons per hour. So that area of that one little square is really interesting. And this is the beauty of calculus. You can abstract what you mean by an area. The area of that shape is equal to, base times height. Okay. And the base of it is 1 hour. And the height of it is 50 gallons per hour. And if you look at that, those of you in physics will recognize what happens here. Those of you that are in math should also recognize the units of hours cancel out. And so you literally end up with 50 gallons. And so what that means is every little square down here represents 50 gallons of oil that have gone into the tank. And so you can estimate how much oil has been put into the tank by just calculating the area under here. And if you wanted to take a quick break and just count, in the first 10 hours, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, multiply how many squares you count by 50, you'll have a really good idea of how much oil was added into the tank. But I remind you, they're going to ask you about that, and don't forget your anchor. There were already 1,000 gallons of oil in the tank to begin with. So don't forget about that 1,000 gallons that were already there. Okay, so what does this area tell us about the amount of oil in the tank? It tells that, so this total area here tells us the amount of oil being added into the tank since time zero. The amount of oil in gallons added into the tank from 0 to 10 hours. So that total area is what that represents, okay? This 50 gallons just tells us what one little square represents. Okay, based on the information in the table, what partition has been used for this data? So if you look at this, the data given to us up here, the partition being used is from 0, and remember, the partition is always on the x-axis, 0, 1, 4, 6, 10. And so that is our that's our partition. Okay, how many subdivisions or subintervals should we use for this Riemann sum? Well, we have 1, 2, 3, 4. We have 4 subintervals. So the answer to this is going to be 4. Okay, whenever we use a Riemann sum, we have to decide what values to choose to calculate the height of each rectangle. Suppose we're asked to calculate a left Riemann sum. So what that means is on every subinterval, we always choose the left edge. Okay, so what would happen then is we would say that this first rectangle's height is 250. The second rectangle's height, we would say, is this number here, 240. Okay, and you guys recognize right away that that rectangle's area, that's going to be an overestimate because we're adding on this amount of oil that really wasn't being added into the tank. This function is a decreasing function. So what would happen here is if we do that left Riemann sum, we're going to overestimate the amount of oil in the tank. If we ask to do a left Riemann sum, it will overestimate. The amount of oil because the function is decreasing. And that's the exact wording you should use when it's asking about this. It tells us that it is decreasing. So it will overestimate the amount of oil because the function is decreasing. So every point in time that we choose, all the points after that are always lower because they said the function was decreasing. So it would be an overestimate. Okay, conversely, suppose we were asked to calculate a right Riemann sum. Will this overestimate or underestimate the amount of oil in the tank? And so this time it will be an underestimate. They will not ask you both of these on the AP test. They'll just ask you for one of them, and you do one or the other. It says would it overestimate or underestimate? In this case, it's an underestimate because this first rectangle, we're going to use the right edge. So we're going to say, oh, the first rectangle is only 240 gallons per hour of height, which we know is the lowest possible answer here. So this would be an underestimate. So it will underestimate. It will underestimate the oil because function is decreasing. Okay, and once again, Google keeps me busy here when I try to just have myself in this meeting. I have to tell it I'm still actually here. Okay, alrighty. Okay, determine the values for the first interval that we'll choose for a right Riemann sum. So C sub 1 is, we're going to choose the right edge. So that's going to be here. That's 1 hour. C sub 2, okay, you can't see the graph and the table and my video all at the same time. So I'm trusting you have the notes in front of you there. So I'll focus here on this. So C sub 2 would be this second one, which is at time 4. So that would be the right edge of that second one. The third subinterval is going to end here at 6. And the last subinterval is going to end at time 10 because it says use those for a right Riemann sum. Okay, then it says calculate the area of the first rectangle using a right Riemann sum. So the area is just base times height. Okay, the first subinterval's width was 1 unit, 1, and its height, we said right Riemann sum, 240. Okay, and this information is coming directly out of the table here. So we know that this first subinterval is 1 unit wide, and on the right edge of that, it's 240. And so I'm going to take this width 1, multiply by 240. Okay, and so that is equal to 240 gallons of oil that went into the tank in that first hour. Okay, the second area is base times height. And in this case, that second rectangle's width, it goes from 1 hour to 4 hours. So that's 3. So I have 3 hours times its height. And we're told to do the right Riemann sum. And so this point right here is listed in the table there as 190. So that would be 190. And that's how many gallons total we have here. I think I get 570 for this. So 570 gallons. Okay, and something to think about is that the width does not matter. The width of the rectangle, they can all be different. When I say it doesn't matter, they don't have to be the same, is I guess a better way of putting that. So here is our second rectangle. That is approximately 570 gallons. Okay, our third, its base times its height. The width of the third is between 4 and 6. That would be 2 hours times, and then the height of that one, well, we have to use the right edge at 6. And in the table, the right edge at 6, it tells us right here is 150. So I do 2 times 150, or 300 gallons. All right, and then the fourth one, again, I have to use the base times height. The base of this fourth rectangle is 4 units, 4 hours. And I multiply it by the height of the right edge. We get to choose that height. We get to choose the 10, and then the height at 10 we know is 140. So I do 4 by 140. And so I end up with 4 times 140, which is 560 gallons. Okay, so total area isn't really an area. It's how many gallons there are. So basically, I add the 240 plus the 570 plus the 300 plus the 560. Okay, and you guys, if I make a mistake on this, you get the concept of what I'm doing here. I'm just adding up those 4 rectangles. So 240 plus 570 plus 300 plus 560. And I end up with 1,670 gallons. Okay, now this is a kicker. How many gallons of oil are in the tank at 10 hours? Typically, they will not ask you this question about what is the total area. They won't generally ask you that question. They will go straight to here. And what most students will say is they will say 1,670 gallons, and that's wrong, okay? Because you have to remember that anchor point, that there was initially already 1,000 gallons in there to begin with, plus the 1,670 that you added in, okay? So very, very important that you include that initial condition, okay? And so we end up with 2,670 gallons. Okay, one thing that is really important for you guys to recognize is the way this problem is structured is there's only one correct answer, okay? So typically they will not ask you in this many sub pieces all of these questions. They will generally ask you to, estimate the amount of oil in the tank at 10 hours using a right Riemann sum, and then that's your job. So they will give you some points for choosing the right edge of each rectangular area. It has to be the right edge, and that you correctly calculate an area. This would typically be 2 or 3 points total. Because it talks about units on this, in some places, they might give you a point for the units as well. Okay, so just be mindful of the units here. 2,670 gallons is the correct units there. Okay, alrighty guys, I will see you at the next video. Okay, bye-bye.